In this video, we'll be talking about the concept of function. Calculus is about function, and I use the word function in the first sentence because we can't go forward without it. Like all other words, we learn this one in two different ways. The first one is we define the word, and the second one is we use the word. And I believe that seeing example of function and using the word to explain those examples is a fast and powerful way to learn. So before we use an example of function, why don't we know what function is composed of? Function is composed of a domain set, a range set, and a set of rules that that attach a domain to its corresponding range. You understand? Now, the definition of function, please, has no restriction on nature of the elements of the two sets, because I mentioned now we have two basic sets, which is the domain sets and the range sets. You now see these domain sets and the range sets, they are variables, which means we can say that function is a rule that is associated with variables. It is associated with variables. That is why I said that it is composed of the domain sets, the range sets, and rule correspondence that assign exactly one element of range to each element of domain. So we can say that a function is a rule that is associated with variables. Now, any quantities which may assume unlimited range of numbers is what we refer to as variables, and any quantities that remain unchanged is what we refer to as constants. So by this, we can say that we have two types of variables, and those are the dependent variable and the independent variable. These are the two variables that we're having. You understand? Now, when a variable quantity depends upon another, a variable quantities depend upon another, it means that the value of the latter determines the value of the former. You understand? And the former is said to be the function of the latter. I get what I'm trying to say now. Because we are trying to say that one is independent and the other one is dependent. What we are trying to say is that any value that we get for a dependent, it depends. Any value that we have for the dependent depends on the value of the independent. Therefore, we can say that a dependent variable, a dependent variable is a function of independent variable. It is a function of independent variable. That's the first thing I want you to know. You understand? So we are now going to represent this mathematically. Now, what are dependent variable? What is the symbol, mathematical symbol that we use for denoting the dependent variable? That is y. So a dependent variable is also represented with y. Understand? And an independent variable is x. Dependent variable is y, and an independent variable is x, which means if you want to write this particular statement mathematically, we can write it as y is a function of x. Therefore, y equals to f of x. So that is where we have that. Dependent variable is a function of independent variable. Therefore, y equals to function of x. So the distinction between f and f of x should be kept in mind. F denotes function. You understand? Ordinary F denotes function. And f of x denotes function of x. And you have to understand that function of x is the same thing as what? Is the same thing as y, because y equals to function of x. You understand? So this y is what we refer to as the range. And these x that is here is what we refer to as the domain. So the range is a dependent variable, is an independent variable, dependent variable, and the domain is an independent variable. You understand? So in other words, we said that it contains the domain sets and the range sets. We are equally saying that it contains of what? It contains of x-axis and y, rather x and y, not axis, x and y, where our x is independent variable and our y is dependent variable. So we can also call these dependent and independent. We can also call it inputs, inputs, and we can call this y. We can call it output. You know that anything that you have as an output depends on what you input inside it. So something like this, you can have like a machine. Let me say just like a machine. We have a machine like this. Now this machine is giving us a particular output. Now this output that this machine is giving us depends on what we put in, depends on the inputs. It is just like we're having a blender, you understand? And this blender, what it blends is pepper. It blends a pepper. What we that is our input, you understand? We put pepper inside the blender. What we'll be expecting to come outside of the blender is grinded pepper. We will not, we cannot expect a fruit to come outside of what we put pepper inside. So it shows that an output depends on the input. Therefore, we can say that this one is what? This one is range, or y, while this one is what? Is domain, or x. That is what we are trying to explain there. Now, let's now talk about graph of a function. You see, a function f establishes a set of other pairs. That is, and these other pairs are real numbers. And those other pairs, we are talking about graph of function now. Graph of function. And you know that in a graph, we have two axes. That is what? That is y-axis and the x-axis. Same thing as the graph of function as well. I get what I'm trying to say now. So a graph of function has a set of ordered pairs of real numbers. And these are what? These are y-axis and x-axis, and we represent it as x, comma y. You understand? Now, you know that y, we have already said that y is a function of x, right? We have already mentioned that, so that y is a function of x. Therefore, we can rewrite this as what? We can write it as x, comma f of x. And this is a coordinate system in which the graph of function is being plotted on. And the result can be thought of as a pictorial representation of the function. Now, let us take three examples when we are talking about a graphical representation of a function. We are going to be taking the first one to be linear function. The second one is the squaring function. And the third one is the exponential function. So the linear function, we have our f of x, let me say equals to 2x. The second one, we have our function of x, let me say it to be equals to x squared. And the third one, let's say our third one is now equals to 2x to the power 2, 2x to the power x rather. So this is a linear function, this is a squaring function, and this is an exponential function. Now, the three of them are not the same, although the three of them include the number 2 and letter x, but they are very different. And we can see their difference when we draw their graph. You understand? For this linear function, it is going to give us a linear graph, something like this. Something like this. Coming. It's going to be giving us a linear graph like this. You understand? And if it is the second one, which is the squaring function, so this is a linear function. This is a linear graph or a line. So it's a linear graph. The second one, which is squaring function, is going to give us a parabola. I'm coming, trying to plot that. So it's going to give us a parabola, something like this. Something like this. So this is a parabola for squaring function. And the third one is going to give us an exponential curve. You understand? An exponential curve, which is something like this. Which is something like this. It will not start from the origin. You understand? It's going to give us an exponential curve. So this is an exponential function. So you can see that there are difference when we plot their graph. You understand? So in this one is going to give us a linear graph. This one is going to give us a parabola graph. And this one is going to give us an exponential graph. We don't want to plug in our values because we are not there yet. Let us just understand that this exponential, for example, 2 raised power x, this is linear. This is a squaring function, for example, x is power 2. And this is a linear function, for example, 2x. These are their graphs, you understand? Now, we now want to do some example to decide whether there are relations of function. You understand? We want to decide whether an equation defines a function, because if it defines a function, it will be helpful it will make us to know if a particular formula is denoting that y is a function of x. You understand? So to decide whether an equation defines a function, it is helpful to isolate the dependent variable on the left hand side. And remember, what is the dependent variable? That is the what? That is the y. For example, let us take number one. X plus y equals 1. Now, I said it is helpful to isolate the dependent variable on the left hand side, and this is the left hand side. So the first thing you're going to do is what? Take this x back to the to the back. You understand? Therefore, my y will now be equals to 1 plus x. And if you look at it very well, if you see that the value of x, for every one value of x, there is only one value of y. Therefore, y is a function of x. You understand? For every one value of x, there is only one value of y. Therefore, y is a function of x. For example, if the value of x here equals to 2, therefore the value of y will be equals to 3. That is what you are trying to say. So we can see that for every value of x, one value of x, there is always one value of y. You understand? Therefore, we can say that for this one, y is a function of x. Now, what if we have another question like this? Another question like x squared plus y squared equals 1. For example, remember I told you the first thing is to isolate the dependent variable on the left hand side. So what we're just going to do is take this x to the back. We're going to have y squared equals to 1 minus x squared. Now what you are looking for is y itself. So what you're just going to do is we are going to root the both side. Therefore, my y will now be equals to, now since I'm having a root and we are dealing with function, therefore it's going to be plus or minus root of 1 minus x squared. So what we are trying to say here is that for every value of x, there are two value of y, which means in this case, y is not a function of x. That is what you are trying to say here. Y is not a function of x. Why is it not a function of x is because of those plus or minus. So whenever you're having a root, you understand? Whenever you're having a root, it means it cannot be a function because the dependent variables will now have two values for every value of independent variable. So it does not define a function. For example, if x equals to, let me take for an example, let me say x equals to 3 in this case, x equals to 3. Therefore, my y will now be equals to plus or minus root 8, which means my y can be equals to plus root 8 or it can be minus root 8. So you will see that I have only one value of x, but I'm having two values of y. Therefore, y does not define a function. That is what they are trying to say. Where this one, it means that one will be positive and the other one will be negative. You understand? So whenever you're having a root, you are seeing a plus or minus sign. Therefore, y is not a function of x. Let us take an example. Let us say we have something like x squared plus y equals to 2, for example. So the first thing we are going to do, isolate this at the back. Therefore, my y will be equals to what? Will be equals to 2 minus x squared. This one, is it a function or not? Yes, it is a function. Why? Because we did not have a root. Y is just y. So it means that if x equals to 2, if x equals to 2, it means my y will be equals to minus 2. Are you getting what I'm trying to say? If x equals to 2, it means my y will be equals to minus 2. So you can see that for every single value of x, I have only single value of y. But what if it is now x plus y squared equals to 2? So I'm going to be having y squared to be equals to 2 minus x, and I'll have to root it. You understand? Therefore, my y will now be equals to plus or minus root 2 minus x. And that is what it means that it is not a function. Why? Because for every value of y, for every value of x, I'll be having two values of y. You understand? So that is what they are trying to say here. You understand? So it is going to be given a 2 points. It is going to be given a 2 points. For example, if this one is 6, for example, now, if this one is no, if this one is, let me say, we have, for example, this particular one that we have here, it is now 0. This x is 0. So y equals to plus or minus root of 1 minus 0. You understand? You know that will be y equals to plus or minus root 1, which means my y will be equals to plus or minus 1. You understand? Therefore, it's going to give me y equals to plus 1 or y equals to minus 1. It means that if I want to plot the graph, remember I told you that if we want to plot the graph will be x comma y, right? I've already mentioned that. Therefore, it means my graph will be having 2 points, and these points are either it is 0 and 1 or 0 and minus 1. You understand? That is what it is. That is what we are trying to say. You understand? So it means it's going to give you 2 points. You understand? So that is that about that. That is how to determine whether it is something is a function or not. So this is where we'll be stopping in this particular video. In the next video, we'll be talking about the different types of function that we have. And thank you.